All right, in this video, I'm going to go over finding the domain of a function. Just going to concern ourselves with the domain for this video and get to range later. So for the first set, all I have is a set of ordered pairs. Now for ordered pairs, all we need to do is list all the numbers in the domain. Now, what is the domain? It's the input, right? So what is the input in an ordered pair? It's the number on the left, right? Like, it's the first number. You input a -5 and you get out 4. That's kind of what the whole ordered pair notation is for. So we just list out all these numbers, but we have to list them in a specific order from least to greatest. And it just so happens that they have these ordered pairs in order from least to greatest. In terms of the domain anyways. The range, however, actually gets lower. But like I said, we're not doing that in this video. Just concerning ourselves with the domain, just the input for now. All right, so what about this one? There are no limits to the numbers that we can put into this function. Absolutely none. I'll go over how I know that later on. But I can't just list out every single number that there is. We need to use interval notation. So our domain is -infinity to +infinity, or all real numbers. Another way to say that. All right. So set of ordered pairs, you just list out all the inputs for a function. Most functions, the domain is going to be infinite. Now, what happens? I mean, what could possibly happen to keep our domain from being infinite? Well, we can't have 0 in the denominator, so look out for that. Can't do this. So if you have a denominator with a variable in it, then your domain is not going to be all real numbers. Just stop right there. So what do? What is the domain? Well, we take that entire denominator and we set it equal to 0. Well, wait a minute. I thought the denominator could not be 0. That's exactly what we're trying to figure out. We're trying to figure out what is not 0. So what I do when I do problems like these is I put a strike through the equal sign, because I'm trying to figure out what x cannot equal. And the 2 minus x cannot equal 0, right? And now we solve for x just like normal algebra, right? Subtract 2 from both sides. Divide by a negative, right? Or multiply by a negative, either way. Same thing happens. Don't forget that strike through, like I just did. So x cannot be +2. All right, but it could be anything else. So what do we do with our interval notation? Well, we in our interval notation, we always start with the lowest number first, right? So we can go all the way to -infinity. We just can't hit 2, right? And do we include 2? No. We do not include 2, all right? But we're not done yet. Can we go above 2? Yeah, Sure, 2 minus 3, it's negative 1. I mean, it's still not 0. So yeah, that would be okay. So we put this symbol in there, which means in union with. So we have this section of our domain in union with 2 to positive infinity. That's just the interval notation way of saying all real numbers except for the number 2. For some reason, we don't like the number 2 in this particular function. It's just undefined. We can't figure it out. But that is one thing you got to look for. If you have a denominator, make sure if there's a variable in there that you figure out which value or values it needs to be to make that denominator 0, because it cannot. X cannot be that number that makes that denominator 0. All right, a couple more examples. Number 4 here, we have a square root with a variable underneath it. That's the other thing we got to watch out for. Got to watch out that we don't have a denominator equal to 0, and anything under a radical, which is called a radicand, by the way. If you don't remember that, listen. Radicand. Radicand must be greater than or equal to 0. Why? Well, you can't take the square root of a negative number, right? That would be an imaginary number, I, or a variation of I. And that is why. Only 2 things you need to watch out for. Square roots with a variable underneath them, and denominators with a variable underneath them. Square roots specifically, okay? If you have a cube root, that's fine. If you have a 4th root, that cannot be less than 0 either, because it's even. Anything with an even number must be greater than or equal to 0. Any root with an even number, even numbered roots, or even root, if you know what that is. I hope you remember. If you say even root, then it must be greater than or equal to 0. If it's odd root, then it's fine. All right, so what do? We take that radicand, 5 plus 2x, and we say it must be greater than or equal to 0, right? Solve for x again. Subtract 5 from both sides. 2x is greater than or equal to negative 5. Divide both sides by 2. X is greater than or equal to negative 5 halves. And yes, you can just leave that fraction like that. Are we done? No, we got to write this in interval notation, starting with the lowest number. Now we use brackets because we're using interval notation, right? And we're including the negative 5 halves. And that's our lowest number, right? Because x, our domain, x, is greater than negative 5 halves. So we start at negative 5 halves and we go to the right forever. The positive direction, getting greater and greater. All right. Now, number 5, save the best for last, right? Oh, well, look what we got. We got a denominator with a variable, and we got an even root with a variable under it. So we need to do both in this case. 2x minus 1 cannot be 0. And that radicand, 1 plus 4x, must be greater than or equal to 0. Or we're going to have problems. All right? So what do we do? Plus 1, plus 1. 2x cannot equal positive 1. Divided by 2, right? X cannot equal 1/2. Okay, that's part of it. Let's do the radicand part. Divide both sides by 4, right? X is greater than or equal to negative 1/4. Okay, so what's the domain of this one? Well, can't be anything less than negative 1/4. So it must be greater than negative 1/4. So we're including negative 1/4 in this. And do we go all the way to infinity? Is 1/2 greater than negative 1/4? Yeah, that's negative. This is positive. So it goes all the way to 1/2 and stops, skips over 1/2. And then there's that union sign again, the or. Still skipping over 1/2. So we don't want to include that for some reason. Poor 1/2 gets left out. And then we keep going on to positive infinity because x is greater than or equal to negative 1/4. All right, makes sense? Because we can't go lower than negative 1/4 or we get negative, right? So we go from negative 1/4 all the way up to 1/2, and then suddenly we got to jump and keep going. Think of it in decimal terms as 1/2 is 0.5, then 0.501 is okay, and 0.49 is okay, but 0.5 exactly, not okay. It's going to be undefined. And there you have it. Thank you for watching.